This is review for chapter 6.1 through 6.3, the first half of chapter 6. And let's get started here. 6.1 was the polygon angle sum theorems. Let's see what our problem asks us to do. Find the sum of the interior angle measures for each polygon. So we know that the sum of the interior angles, and this is for any polygon, is the quantity of the number of sides minus 2 times 180. So let's start with our first one here. Octagon tells us that n equals 8. So the sum of the interior angles is 8 minus 2 times 180. So that's 6 times 180. And the sum of the interior angles of an octagon is 1080 degrees. And next, a 42gon. That just tells us that the number of sides is 42. And we just put it into our formula. 42 minus 2 times 180. That's 40 times 180. The sum of the interior angles of a 42gon is 7,200. It's a lot of angles. All right, so those were pretty easy. What's next? Find the missing angle measures. All right, well, this is like our triangle angle sum theorem, but we have to do a little work first because not being a triangle, we have to figure out what the sum of the measures is. So we know that n equals 5, and the sum of the interior angles is 5 minus 2 times 180, which is just 3 times 180, which is just 540. And if you know your figures, you know that that's true for every pentagon. So now we can just do the problem like we would any other sum theorem. And x plus 5 plus 106 plus 94 plus 135 equals 540. So 2x plus 340 equals 540. It's just algebra now. Subtract 340 from both sides. 2x equals 200. So divide by 2. And we get x equals 100. So this angle right here is 100 degrees, and this angle is 105 degrees, which fits in with everybody else. All right, that was another easy set of problems. Let's see what's next. Find the measure of one interior angle and one exterior angle in a regular polygon. So we know these are special, and we have formulas for this as well. Measure of an interior angle, measure of one interior angle for a regular polygon is n minus 2 times 180. Our total, divided by the number of sides. And we also know that the measure of one exterior angle of a regular polygon is, what do we know about exterior angles? We know the total is always 360, and we can divide that by the number of sides. So let's do our first problem here. Nonagon. Nonagon means 9, and it equals 9. And so the measure of one interior angle is 9 minus 2 times 180 divided by 9. And that equals 7 times 180 divided by 9, which is what? 1260 divided by 9. So the measure of one interior angle is 140 degrees in our nonagon. Now, what do we know about interior and exterior angles? Let's say we've got just a figure here, some random figure, and then that is going to make our angles. So we have an exterior angle and an interior angle. What do we know about those two? We know that they're linear pairs. So there's a couple of ways that we could go about this. If we know the interior angle is 140, what's the exterior angle going to be? That's right, it's going to be 40. But we also have a formula. Measure of our exterior angle of our regular polygon is 360 divided by the number of sides divided by 9 equals 40 degrees. So if you remember that it's a linear pair, it's straightforward, it's easy. Or you can use your formulas. They both work. Let's do our 20gon. That tells us that n equals 20. So the measure of our interior angle is 20 minus 2 times 180. That gives us our sum, our total, and then divided by the number of sides. And that is 18 times 180 divided by 20, which is 3240 divided by 20. So our interior angle is 162 degrees. So what's our exterior angle going to be? That's right. Or we can do 360 divided by 20. Both ways, 18 degrees. So those were easy. Just know what it is you're doing. You know that you can find the sum of the interior angles based on the number of sides. If it's a regular polygon, you take that sum and divide it by the number of sides. We know the sum of the exterior angles of every polygon is 360. And if it's a regular polygon, we can find one of those exterior angles by dividing by the number of sides. And don't forget these formulas because they work backwards as well. You can be given an angle and use it to find the number of sides. I would be able to do that if I were you. All right, 6.2. This is where we hit parallelograms. Yay, I like parallelograms. They're fun. What are we asked to do? Find the value of the variables. I assume we were supposed to justify our answer here. All right, well, how are we going to do this? Well, I bet we can find x. What's going to let us find x here? If this is a parallelogram, I know that consecutive angles are supplementary. So I know that 8x plus 7x is 180. So 15x is 180 divided by 15 on both sides, just algebra now. So x is 12. There's my first one. Now, what else do I know? Well, I know that opposite angles are congruent. So I can say that 7x equals 12y, or 7x and equals y. And say that y equals 7x. And 7 times 12 makes this 84 degrees. I can't help myself, makes this 96 degrees as well. So if this is 84 degrees, y equals 7 times 12. Then this has to be 84 degrees as well. So we used both of our angle properties. All right, what's the next problem? We're looking at diagonals. It's a parallelogram. What do we know about the diagonals of a parallelogram? We know that diagonals bisect. So I know that this and this are congruent, and this are congruent. So that's just a matter of writing equations. And my first one is y equals 3x plus 1, and my second equation is y plus 15 equals 5x. So, oh no, we have a system of equations here. I'm just going to use substitution because I already have a y. This y, I know that y equals 3x plus 1, so I'm just going to put that in for y. So 3x plus 1 plus 15 equals 5x. And then subtract 3x from both sides. So 16 equals 2x divided by 2. And x equals 8. So if x equals 8, then what can I do? I just come over here and take my y equation, and y equals 3 times 8 plus 1. So that's 24 plus 1, y equals 25. Now if I look at these, it means this one, this length right here is 25. What's x? 3 times 8 is 24, plus 1 is 25. Of course it is. Pardon me. And 5 times 8 is 40, and 25 plus 15 is 40. So yay, it all works out. All right, last problem here. Parallelogram. What do we know about our parallelogram here? We know that opposite sides, pardon me, are congruent. So I know that this and this are congruent, and this are congruent. So this one's easy enough. 3x plus 1 equals 5x minus 1. It's nice to have all of our variables in the same variables on the problem. Add 1 to both sides. 2 equals 2x. So x equals 1. And then my other equation is 2y minus 9 equals y minus 2. Subtract y from both sides. I get y minus 9 is negative 2. Don't lose your negatives there. Be careful. Add 9 to both sides. Y equals 7. And if we put it back in, we're going to get the same answer. 7 minus 2, that would be 5. 2 times 7 is 14. Minus 9 is going to be 5. And if I do my x's, 5 times 1 is 5 minus 1 is 4. And 3 times 1 is 3 plus 1 is 4. So our sides are congruent. All right, that's just a matter of doing algebra based on our properties of parallelograms. All right, and oh, I see parallel lines. In the figure, we are told that the length of BD equals the length of DF. So I'm going to find BD. That and that are congruent. Definition of congruence. Find the length of DG and EG. So who am I looking for here? There's DG and EG. So what do I know? Well, I have 3 parallel lines cut by a transversal, and my transversal here is cut into congruent segments. That means every other transversal is going to be cut into congruent segments. So I know the length of AD, well, I know that AD is going to be congruent to DG, and I know that the length of AD is 3.2, so the length of DG is equal to the length of AD is equal to 3.2 units long. And it's going to be the same for this one. I know that EG is going to be congruent to CE, and so the length of EG equals the length of CE, which is 2.05 units. So that was really easy. Just got to recognize that if you've got 3 or more parallel lines and congruent segments on a transversal, all other transversals have congruent segments. Yay, those were fun. All right, and 6.3, we're at the end here. Based on the markings, are the figures going to be a parallelogram? Justify. Well, what's going on in our first one? Yes, this is by definition of a parallelogram. We've got both pairs of opposite sides are parallel. Woohoo! What about the next one? Yes, it's a parallelogram. Both pairs of opposite angles are congruent. That's parallelogram. And what's next here? Parallelogram? Yes. The diagonals bisect each other. So parallelogram. What about this last one? Aw, no. It's not the correct sides. This one was, it had to be parallel and congruent on the same side. So it might be a parallelogram, but we can't prove it. So that was really easy. Know your formulas for the angles of the interior and exterior angles of polygons. There's 4 of them. 2 work for every polygon. 2 of them work for regular polygons only. And then know your properties of parallelograms. By definition, opposite sides are parallel. Theorems, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. And our fancy little new thing here, we can tell that it's a parallelogram if one pair of opposite sides is both congruent and parallel, which unfortunately that last one was not. So know your quadrilateral classifications, and I think that you will do really well on these problems.